Okay, this is my solutions video for the study guide that was provided for the material on circular motion and gravitation. So the first one is, what is the angular speed in radians per second of a flywheel that is turning at 813 revolutions per minute? And they want the angular speed in radians per second. So it was given to us in revs per minute, so 813 revs per, that's a division, minute, and we were asked to provide it in radians per second. So we know that we have 1 rev is equal to 360 degrees, which is also equal to 2 pi radians. So I'm going to convert the revs. So 1 rev is equal to 2 pi radians. And my revs now will cancel. And I need to get rid of the minutes. So 1 minute is equal to 60 seconds. And you'll notice now that minutes cancel. And the only thing that I'm left with are radians and seconds. And if I plug that into my calculator, I will get that answer to be 85.14 rads per second, and that will be letter D. The original material or answer, I'm sorry, the original angular velocity was given in 4 sig figs, and my answer is in 4 sig figs. Through how many degrees does a 33 rev per minute turntable rotate in 32 seconds? Well, we were given the angular speed as 33 revs per minute. We were asked, or we were given the time of 0.32 seconds. We know that the definition of angular speed is the change in position over time, or change in time. We'll assume that time initial is 0. And so if I want to know how many degrees the turntable went through, I'm looking for the change in position. That's what the question is asking, but they want it in degrees. So I'll rearrange the definition of angular speed for the variable that I'm looking for, times time, and I'll plug in some numbers and convert to get the units that they asked for. So 33 revs per minute, and I have a time that I need to multiply, 0.32 seconds, and now I need to convert, and my answer needs to be in degrees, so degrees. So I know that 1 rev is equal to 360 degrees. Notice now that my revolution canceled. I'm left with degrees on top. And I see that I have seconds on top and minute on the bottom. So I need to get rid of my minutes. And so I will put 1 minute up top is equal to 60 seconds. And now my seconds cancel, my minute cancel, everything cancels except for my degrees. And that's what I want my answer to be in. And I will find, if I plug that into my calculator, that the answer is 63.4 degrees. And they gave it to me in 2 sig figs, so that'll be 63 degrees. So the answer is B. Okay. A chicken is running in a circular path with an angular speed of 1.52 radians per second. How long does it take the chicken to complete 1 rev? So let's discuss what was given. I have an angular speed of 1.52 rads per second. How long, that's what they're asking for, to complete 1 revolution. And that 1 revolution is my angular displacement. I have an equation that relates all three of the variables to one another. The angular speed is equal to the change in position versus time. We're looking for time, so we'll change that or rearrange that equation for time. We get angular displacement divided by angular speed, and they want the answer to be in seconds because I can see all my answers are in seconds. They didn't specifically state that. So let's go ahead and put in what we know. We have 1 rev divided by its angular speed, which is 1.52 radians. And then I have per second, so a second goes up top. And now I need to I need to convert the revs to radians. So 1 rev is equal to 2 pi radians. And then I'll notice that revs cancel, radians now cancel. My only unit left is seconds. And so if I plug that into my equation, I get 4.13, or my calculator, 4.13 seconds. The data was 3 sig figs that were given. My answer will be in 3 sig figs, and I'll find that the answer is D. Number 4, when a fan is turned off, its angular speed decreases from 10 rads per second to 6.3 rads per second in 5 seconds. What is the magnitude of the angular acceleration of the fan? Well, what was the data given? The initial angular speed is 10 rads per second. The final angular speed is 6.3 radians per second, and the time that was given was 5 seconds. Everything was given to us in 2 sig figs except for 10. 10 is 1 sig fig. And we were asked for the angular acceleration. 2 ways to think about how to solve this. The definition of angular acceleration is change in angular speed over change in time. We'll assume time initial is 0. So we can solve it that way. But it's also, in fact, actually, the angular speed final equals the angular speed initial plus the time times the angular acceleration. If I rearrange that equation, I will get final minus initial over time. Those two equations are the same. In fact, that's where that first kinematic equation came from. So I'll go ahead and put in final minus initial. So I have 6.3 radians per second minus 10 radians per second. That is the subtraction, so I'm going to put that in parentheses. And then I'm going to divide by seconds. My units for that will be radians per second divided by seconds, so that will give me radians per second squared. And that is what I would expect to get for an angular acceleration. And if I plug that into my calculator, I will find the angular acceleration to be negative 0.74. Now notice they asked for the magnitude, so I will drop the negative. And that will be letter E as my answer. Number 5, as you start riding a bicycle, the wheel begins at rest and has an angular acceleration of 2.5 radians per second squared. What is the angular speed after 5.1 seconds? So let's write down everything that we know. Well, this rest means that the initial angular speed is 0. The angular acceleration was given at 2.5 radians per second squared. What is the angular speed after a period of time? So that is the question, that's the final angular speed, after 5.1 seconds. The 5, 4, 3, 2, 1 problem, just like the one previous. I'm looking for final angular speed. I can use my favorite equation from my kinematics, alpha times time, and rearrange the question. Well, I don't have to rearrange anything. 0 plus 2.5 radians per second squared times 5.1 seconds. Notice that one of my seconds cancels. I get a radian per second as a unit for my answer. And if you plug that into your equation, or to your calculator, you'll get 12.75 radians per second. And that will be rounded to 2 sig figs, is 13 radians per second. Number 6, a child pedals a tricycle given the large wheel and angular speed of 0.458 revs per second. If the radius of the wheel is 0.32 meters, what is the child's linear speed? So we're going to have to go from angular or rotational world to linear world. Notice they asked for linear speed. We will be needing this, what I'll call bridge equation, r times angular speed. Okay, so what was given, they gave me the angular speed of 0.458 revs per second, and they gave me the radius of the wheel, which is 0.32 meters, and they asked for the linear speed. So I have the radius and I have the angular speed, but the angular speed that they gave me is not in units that will work. I have to convert that to radians per second, and so I know that 1 rev is equal to 2 pi radians. Let's see, this is number 6. Yes. Oh, I haven't done that exactly. So I actually like to do my conversions first for you guys. Times 2 times second function pi. That gives me 2.877 rads per second. I'm not going to round till the very end. Now I'll find my linear speed to be equal to 0.32 meters. That's the radius. That's the units I expect. Times 2.877 rads per second. Okay, now my answer will be in meters on top, seconds on the bottom. The radians will go away because we will let that, it's a placeholder, and I should get 0.921 meters per second, and that would be to 2 sig figs B. One more for this solutions video. This is part 1. In order to simulate weightlessness for an astronaut in training, they are flown in a vertical circle. If the passengers are to experience weightlessness, how fast should the airplane be moving at the top of the vertical circle? So I have a vertical circle. Just think about that. Here is the plane. All right. If you think about the person sitting in the seat at the very top and draw a free body diagram of the person is experiencing force of gravity. By the way, this is the axis of rotation. And from the seat, the person will have a force normal. This is similar to a car going over a hill. Okay. In order to feel weightless, we don't feel force of gravity, we feel force normal. To feel weightlessness, or to feel weightless, I need force normal to go to 0. Okay, so the faster and faster you go up and over a hill, the more and more and more you feel like you're coming out of your seat. And if you're going fast enough, you'll actually come out of your seat. And so, in order to solve this problem, let's actually also go through, excuse me, and write down what they gave me. I have a radius of 2.5, and that's all they gave me. And so you're thinking, oh gosh, what do I do? I don't have mass. You'll see it'll end up canceling. So I know this radius of this curvature, r, is 2.5 kilometers. If you convert radius to meters, you got to multiply times 1,000, which will move the decimal point 3 times. I know the radius in meters is 2,500 meters. How do I solve this problem? I'm going to have to apply Newton's second law in the inward direction, and it will equal the mass of the person that's sitting in the seat times the centripetal acceleration. We know that the centripetal acceleration is equal to v squared over r, which is also equal to r times the angular speed squared. They asked for the speed, and they didn't ask for angular speed, so we're going to use the definition of centripetal acceleration of v squared over r. Now, how many forces do we have acting on the person? We have two. We have force of gravity and force normal. Force of gravity is positive because it is pointing towards the axis of rotation. So here's the axis of rotation relative to that free body diagram. So I will have force of gravity, and then I will subtract force normal. It's negative because it points outward of the circle, is equal to the mass of the passenger times v squared over r. Now, if I'm going to feel weightless, then force normal has to go to 0, and we're going to find the velocity at which that occurs. So I'm left with force of gravity acting on the passenger, and force of gravity on Earth is mass times little g, which will equal m times v squared over r. Notice that the mass is on both sides, so if I divide both sides of the equation by m, mass cancels, so the mass of the passenger is not needed in order to answer this question. V is equal to the square root of g times r, and that will be equal to 9.8 times the radius in meters, must be in the correct units, and if I take and multiply 9.8 times 2,500 and take the square root, I get an answer of 156.5 meters per second. The radius was given to us in 2 sig figs, and so v to 2 sig figs is equal to 160 meters per second. And so the answer is C. All right, that's part 1 of the solutions video. And to solve the rest, if you need help with the second part, you can use part 2.